So right now we're putting interest problems on hold for a minute, and we're talking about e as a function, the function y equals e to the x, all right? E to the x is an exponential function where the base is 2.72. So in the last lecture from Monday, we learned all about exponential functions, and so everything we learned applies. And I went to Desmos, and I graphed y equals 2 to the x, and I graphed y equals 3 to the x. All of these exponential functions, of course, go through the point 0, 1, right? Because anything to the 0 power is 1. And so e to the x would go right along in between here. Okay, because it has a base, it'd be closer to 3 than it would be to 2, but it has a base in between 3 and 2. So the range and domain that we gave yesterday for all exponential functions, right, all of those properties apply to the function y equals e to the x as well. Now, when we switch the x and y, and we know that we have found the inverse, we like our functions written in the form of y equals. Well, what's a logarithm? A logarithm is an exponent. All right, so that means when I want to solve this for y, this is written as log to the base e of x. Right, that's the inverse of y equals e to the x. And down here I had said graph both, so, you know, here's my e to the x. And so we know in order to graph the inverse, wow, that actually kind of turned out okay. To graph the inverse, we reflect through the line y equals x. And therefore, this function, if e to the x goes through the point 0, 1, the inverse has to go through the point 1, 0. Right? The inverse is going to look like this. Right? Passing through the point 1, 0. Domain is, that's very important, domain, I cannot input a negative into a log function. That is supposed to be a comma. It doesn't quite look like a comma. 0 to infinity. But when we're talking about log to the base e of x, this is more commonly referred to as natural log. Y equals ln of x. Oops, I should have put this in this blank, and then over in this blank, I should have said and expressed natural log. Okay, so, and how about I wise up and use text boxes when I can, since they are easier in many cases. Okay, so expressed as natural log. And so it's easier to work with natural log rather than logs and other bases. All right, so it talks about it right down here, that this often leads to simpler expressions. That's why we like natural log better than log as in log. Okay, and then just an FYI here, I really haven't talked about this, but if you see log x without a base, it's base 10, right? And that's known as the common log. And so on your calculator, you would have a key that says log, and that would be for a common log, log base 10. And we're going to talk later about how to change bases. It's actually quite easy, the change of base formula. But be aware then, if there is not a base given, it is base 10. All right, but we will prefer to work with natural logs rather than log. So moving on. Wait a minute. Where's that problem? Okay, there was, I wonder if the bottom got chopped off or something. I'm sorry, but oh, this is fine. If g of x is natural log of x and f of x is e to the x, what I want you to find, so take out your calculator and find f of g of x. right? So plug in 3 here, find the natural log of 3, and then when you get an answer to that, the natural log of 3, find e to that answer. Okay, so pause your video for a minute, and again, purposely I wrote these in both of the notations that you could use for composition, just so that you get comfortable on both notations. But pause the video for a minute. Here you're plugging 2 in for x, right, in e, and then you're putting e squared into the natural log on your calculator. So locate these keys on your calculator and go ahead and compute. So remember, natural log and e are inverses of one another, right? So if I plug into here, right, raise e to that power, but then I take the natural log, which I'm putting that answer into the undoing function. So remember, an inverse is an undoing function. I do something, I undo it. So it should not be a surprise to anyone that g of e squared, so if I find the natural log of e squared, and so some of you might have put it in your calculator and rounded off, and so maybe as a final answer you didn't get 2, you got like 1.999, but that's because of rounding. Okay, if you didn't round anything off, when you put this in, you get the same result out. So this is giving us evidence for this rule. Okay, that the natural log of e to the x is x, or if I raise, right, e to the natural log of x is just x. So let's do a couple problems where we're just practicing using e in natural log. Okay, so this comes from Newton's law of cooling and heating, right? I pour a cup of coffee, and that's the temperature T minutes after it's been poured, okay? So this is decreasing. The temperature is decreasing exponentially. I can tell it's decreasing because the growth constant is negative. And if something decreases exponentially, it actually, like if I graphed that, it would look like that. Okay, so it's kind of interesting that when things cool, they don't cool at a constant rate. All right, so it's not like, you know, I pour a hot cup of coffee and it cools by 3 degrees every minute, right, where it's constant. If that happened, I would get a linear function. Okay, so it cools faster the hotter it is, right, and then that cooling levels off. So this should make sense, right? The hotter it is, the further it is from room temperature, the faster it cools. Then it cools slower and slower as time goes on. And then reaches room temperature, right? My horizontal asymptote line would be room temperature. So anyway, this is asking, what is the temperature of the coffee when it's poured? Well, if it's poured, it's time 0. Right? So what that means is if I plug in 0 for t, so I'm going to put a 0 right here, right? And so E, I have to multiply this by 0. Well, that's just 0. So ultimately, I get this. And I better follow order of operations. Even my Calc 2 students who are supposed to be so advanced, that's a 0. They still do silly things like add these first and then do the exponent and multiply. Order of operations says exponents first, then multiply, then add. Of course, in this case, I suppose I could have done it wrong and still get the same answer because this has a value of 1. right? So what I'm really doing is 70 plus 100 times 1. So 170 degrees, and let's attend to precision by writing degrees Fahrenheit, because you guys that are in science, there's a big difference between Fahrenheit and Celsius. So we want to attend to precision and label with units. Okay, so part B asks how long it will take for the coffee to cool to 120 degrees. Okay, so this is where I have to understand my variables, right? So T is time, right? So I'm going to be solving for time, solving for T. And this capital T is the temperature of my coffee. Okay, so this 120 gets plugged in for capital T. So I get 120 equals 70 plus 100, and I'm solving for T. So I'm just, you know what, since it takes me so long to do this, I'm just going to put K, and we can all see that K is this value here. Okay, so I need to solve for T, right? Which means I want to get rid of this 70, right? So subtract 70 from both sides. And I want to get this expression, the expression I'm trying to isolate is this expression. I need to isolate that. So I subtract 70 from both sides. Then, so I have 50 equals e to the kt. Okay. Then I divide both sides by 100. So I'm trying to isolate what I circled here in yellow. Right? Divide both sides by 100. I'm going to get a half equals e to the kt. Okay? Knowing that k is that decimal value up there. Now, how do I get t alone? I'm trying to solve for t. Okay? And what I end up doing is using this, right? Particularly the first part of this, right here. So this is what I'm using. So I'm going to take the natural log of both sides because that's the inverse operation, right? So to solve equations, we do the opposite on both sides. So I'm going to come over here, find the natural log of both sides. And what that does is this results in just the kt. Okay, so I'm going to have natural log of a half equals k times t. So that means I need to divide both sides by k, and k is that decimal up there. Okay, so k comes from up here, and so t is equal to, so when I compute that, I get 15.54. So let's call it about 15 and a half minutes, which that seems kind of long. I don't think I've ever waited 15 and a half minutes after pouring myself a cup of coffee to start sipping on it, but that's how those numbers compute. Okay, so pause the video and try number 9. Okay, so ultimately in number 9, right, the 20 went in here for p of x. Divide both sides by 29.72. And then, so I have to first, before I can take the natural log of both sides, and that is a common mistake. students try to take the natural log of both sides right off the bat. Okay, I can't do that until I isolate e to the x. Okay, now I can take the natural log of both sides, and once I have this isolated, and then I'm down here, I divide by negative 0.2. I have the natural log of this quotient divided by negative 0.02. And my value for x is, where's my work here? Wait a minute. I wrote it on my paper. I can't even read my own writing. I'm sorry about that. About 12, I got 12.68. Okay, so about 12 3/4 of an hour, right? Call it about 12 hours, 40 minutes. Not 3/4 of an hour. I'm sorry, 2/3 of an hour, right? 0.68 is closest to 2/3. So about 12 hours and 40 minutes. So again, let's attend to precision and label with units. Okay, so back to interest rate problems. If I am compounding continuously, okay, so let me get out my eraser since I went all over my workspace here. I'm compounding continuously. That means I use the PERT formula. All right, PERT formula is the exact same formula as the one above with the Q, right? The Q naught and the Q of T. Okay, so here's the PERT formula, and let's set this up together. Okay, so P times e to the RT is equal to the amount. All right, so you invest $10,000. It's compounded continuously. That's how I know I'm using this and not one of the interest formulas that I introduced earlier. E to the RT. Okay, and I want to know how long it's going to take. So I'm going to be solving for T. I want to know how long it's going to take to earn a profit of $500. Okay, so in other words, I'm going to want this to result in, I want my amount to be 10,500. Okay, so I'm going to take this, and so that I don't have to rewrite it, I'm just going to go like this and say I need this amount to equal $10,500. Okay, so again, step one, isolate E. Don't try to take the natural log of both sides too soon. Isolate that. So divide both sides by 10,000, which I should be able to do without my calculator because 1, 2, 3, 4 zeros. Come over here, 1, 2, 3, 4 zeros. Right, so I don't need a calculator to do something like that. Divide both sides by 10,000. Get to here. Right, now I can take the natural log of both sides. And computationally, this is very easy. Okay, so now I'm taking natural log of both sides. And I get the natural log of 1.05 divided by 0.03, and T is equal to, and let's see, T is time in years. Okay, so I get 1.62 years. All right, so about 1 2/3 of a year. So 2/3 of a year, that's about 8 months. So about 1 year and 8 months. Okay, so a few more problems together. Excuse me. Actually, 11. You are going to do 11 for today's classwork. All right, so for today's participation grade, you are going to submit number 11. So number 12, let's look at, let's see, I'm just gonna hop ahead here. How many more? Let's start a new segment. Let's do that. I'm gonna try to make my videos into small chunks. So we'll stop here, take a little break, start a new segment.